Hello, I'm Achal Shrivastava, a CSE 7th semester student of Manipal University, Jaipur. I will be presenting on the topic of neural networks and deep learning. Here are some of the things I will be telling you about. So what is a neural network? Let's first understand a biological neural network. Our nervous system is made up of millions of neurons. These neurons help in carrying messages to the brain and the spine. Let's take an example. When something touches our skin, the neurons present in the area make an electrical change, and this change is passed on to the other neurons till it reaches the brain. This interconnection of neurons is what we call a biological neural network. The artificial neural network is based on a similar manner. They are an attempt at modeling the information processing capabilities of the biological neural system. The nodes in an artificial neural network are equivalent to those of our neurons, whose nodes are connected to each other by synaptic weights or simple weights, equivalent to the synaptic connections between axons and dendrites of the biological neuron. It's time for a history lesson. Neural networks were first proposed in 1944 by Warren McCulloch and Walter Pitts, two University of Chicago neurology researchers who moved to MIT in 1952 as founding members of what's sometimes called the first cognitive science department. The first trainable neural network, the perceptron, was demonstrated by the Cornell University psychologist Frank Rosenblatt in 1957. Perceptron. A perceptron is the building block of neural networks, made up of four parts: input values, weights and bias, summation function, activation function. The input values are affected by predefined weight values and then added up together in the summation function. After the summation function, the value is caught between -1 and 0 or 1 and 0 in the activation function. This will determine if the perceptron will be activated or not. The more negative the value is, the closer it will be to the minimum value, -1 or 0. And then more positive the value, the closer it is to the maximum, that is 1. If it is activated, then the output is sent along its way. If a perceptron is in a single form, i.e. has a single output, then the first and the only output will be in a yes or no format or 0 or 1 format. Single perceptrons are great for linearly separable datasets, which are groups that can be separated using a single line with a constant slope. Perceptrons are excellent for making of AND or XOR logic gates. So what is a neural network? If more than one perceptron is present and joined in a layered fashion, we have produced a neural network. The output for the first layer becomes the input for the second layer, and so on until the output layer sums up the total activation. The total activation is the confidence level of the network for its final decision. Neural network has three parts: the input layer, hidden layer, and the output layer. The input layer is the static point of the network. This is the layer where the values that will be used for the prediction are brought in. The hidden layer is where the network works its magic. This is where the sum and the activation function do their job. The hidden layer can be as small as 1 or as numerous as needed for the project. The last layer is called the output layer, this one. As you can see, each unit is connected to each unit of the subsequent layer. This allows for nearby perceptrons to communicate with one another and create weights that are optimal for their use. How do neural networks learn? Neural networks learn in two steps: feed forward, which we just went over, and backpropagation. In feed forward, we give the inputs, set some weights and balances or bias. These all are summed up and passed through an activation function, after which we get an output, just like we studied earlier. The flow of network is unidirectional and in the forward direction. That's why it's called feed forward network. Backpropagation can be broken down into two steps: calculating the cost and minimizing the cost. The cost is the difference between the predicted value from the network and the expected value from the dataset. The larger the cost, the greater the error. The goal is to have the smallest possible cost. To achieve this, minimizing the cost, we alter the weights and biases using a cost function like gradient descent. So what happens in backpropagation is we first move feed forward. We get an output, we calculate the error from the output, and then we go back. We go to the hidden layers and then make improvements in the weights and balances using the error calculated. This is done to reduce the error in the next feed forward with the new weights and biases. This way, we keep improving our algorithm and reducing the output. Then we move on to the different types of neural networks. There are many types of neural networks, but we are going to focus on these only. The Machalopates model, perceptron, which we did earlier, multilayer perceptron model, CNN or convolutional neural networks, recurrent neural networks or RNN, and Markov chain. Let's start with the earliest model of neural network, the Machalopates model of neuron, 1983. It was proposed in the paper of propagation in 1943. This model is made up of a basic unit called neuron. The main feature of this model is that a weighted sum of inputs signals is compared against a threshold to determine the neuron output. When the sum is greater than or equal to the threshold, the output is 1. When the sum is less than the threshold, the output is 0. This function f, which is also referred to as an activation function or transfer function, is depicted in the figure, where t stands for the threshold. Perceptron. Comes the perceptron model, which we already learnt about. This is the simplest type of neural network that helps with linear or binary classification of data. The learning rule for training the neural network was first introduced with this model. In addition to the variable weight values, the perceptron added an extra input that represents bias or balance. Multi-layer perceptron model. A perceptron that has a single layer of weights can only help in linear or binary data classification. So if the data is not linearly separable, we use a multi-layer perceptron with a non-linear activation function, such as sigmoid. They introduced the concept of hidden layers, the layer which does all sorts of computation in this one. The multi-layer perceptron models are the foundation of deep learning and the upcoming CNN and RNN networks. Convolutional neural network, CNNs, are similar to feed-forward networks, but they are usually utilized for image recognition, pattern recognition, or in computer vision. These networks harness principles from linear algebra, particularly matrix manipulation, to identify patterns within an image. Recurrent neural networks, RNNs, are identified by their feedback loops. These learning algorithms are primarily leveraged when using time series data to make predictions about future outcomes, such as stock market prediction or sales forecasting. They are usually used for speech and audio recognition. Markov chain. A Markov chain is a mathematical system that experiences the transition from one state to another based on some probabilistic rules. The probability of transitioning to any particular state is dependent solely on the current data and the time elapsed. They are very useful in the field of reinforcement learning. Deep learning. So finally, we are moving to deep learning. Deep learning is the subfield of machine learning concerned with algorithms inspired by the structure and function of the brain called artificial neural networks, as we have learned earlier. The adjective deep in deep learning comes from the use of multiple layers in the network. The idea of deep learning rose from the fact that a linear perceptron cannot be used as a universal classifier, and adding hidden layers to accommodate non-linear data could be the key. These multi-layer neural networks were called as deep networks by Geoffrey Hinton in his famous paper on backpropagation in 1986. He is sometimes called the godfather of deep learning. The term deep learning was actually introduced to the machine learning community by Rena Dechter in the same year. So why is deep learning so popular nowadays? Earlier, due to limited amount of data and limited processing power, the feasibility of training deep learning models were low. But since the digitalization of the world, there is no shortage of data. and due to the boom in the gaming industry, the availability of processing power is not a problem anymore, which together has led to the rise of popularity of deep learning. As seen from the graph on your right, with the increase in input data, the performance of machine learning models saturates to a point, whereas for deep learning models, the performance keeps on increasing with the increase in input data. Unlike machine learning models, there is no need to build new features and algorithms because deep learning directly identifies features from the data. Deep learning techniques tend to solve the problem end to end, whereas machine learning techniques need the problem statements to break down to different parts to be solved first and then their results to be combined at the final stage. During test times, deep learning algorithms take much less time to run as compared to machine learning models. All these points tell us that choosing deep learning over machine learning for complex problems is a fair choice. Applications of deep learning. Some applications of deep learning are self-driving cars, news aggregation, fraud news detection, natural language processing, virtual assistants, entertainment, virtual recognition, fraud detection, healthcare, personalizations, detecting development delay in general, colorization of black and white images, adding sound to silent movies, automatic machine translation, automatic handwriting generation, automatic game playing, language translations, pixel restorations, photo descriptions, demographic and election predictions, deep dreaming, and much more. So, at the end, I want to thank my teacher, Mrs. Bali Devi. Without her guidance and support, this would not have been possible. So, we have come to an end of the PPT. Thank you for listening. This is Achin Srivastava, and that's all, folks.